Example 11. A cylindrical container has a height of 100 centimeters. The container was initially full of water, but there is a leak in the base of the container. Ryan noticed the leak in the container when it was dripping at a rate of a half centimeter per minute, and the container was half full. The rate at which the container is leaking is proportional to the root of h, where h is the depth of water remaining. We are to A, show that this leads to the differential equation dH by dt is equal to minus 1 over 10 root 2 multiplied by the root of h, where t is time in minutes. B, we are to obtain the general solution of the equation, and t and c, we're to find t when h is equal to 50. All right, so let's start by including some information we got from reading the question. For starters, we got the boundary condition. H is equal to 100 when t is equal to 0. Now, we got that information from the fact that the height of the cylinder is 100 centimeters and the cylinder is initially full. The second boundary condition we got is that dH by dt is equal to minus a half, and this is when h is equal to 50. All right, so we got that from the fact that he said that the rate at which the container was leaking when it was half full is a half. So dH by dt here is negative because the height is decreasing. Next, so A, we're told that the height, the rate at which the height is decreasing, dH by dt, is equal to k times the root of h. So where did we get this from? We're told that dH by dt is proportional to the root of h. If it's proportional to the root of h, it is equal to k times the root of h. K here is the constant of proportionality. All right, so let's apply a boundary condition. We're going to apply the second boundary condition, which says that dH by dt is equal to minus a half, and this is when h is equal to 50. Now, the root of 50 is the same as saying 5 root 2, so minus a half is equal to k times 5 root 2. So therefore, I can say that k is equal to minus 1 over 2 times 5, 10 root 2. So therefore, the differential equation would be dH by dt is equal to k, which is minus 1 over 10 root 2 times the root of h. All right, so we've just accomplished A. Let's move on to B. All right, so at B, we're to find the general equation, the general solution of the differential equation. Now, the differential equation is dH by dt is equal to minus 1 over 10, the root of 2 times the root of h. All right, I can change this to dH over the root of h, which is h to the 1/2 power, is equal to minus 1 over 10, the root of 2 dt. Next, we can integrate both sides. If we integrate both sides, we're going to get here h to the 1/2. First, it was h to the minus a half. Therefore, I would increase the power by 1. Minus a half plus 1 is a positive a half. Then I would divide by the new power, which is a half, and this would be equal to minus 1 over 10, the root of 2 times t plus c, which is the constant of integration. All right, so dividing by a half is the same as saying multiply by 2. So 2 times the root of h, h to the power of a half is the same as saying the root of h, is equal to minus 1 over 10 root 2t plus 8 plus c. Now I'm going to apply the first boundary condition so that I can determine the value of c. And the first boundary condition is that when t is equal to 0, h is 100. So h is 100 when t is equal to 0 is the boundary condition that I'm going to apply. So this is 2 times the root of 100 is equal to minus 1 over 10 times the root of 2 times 0 plus c. Now the root of 100 is 10. 10 times 2 is 20. So c is equal to 20. So my differential equation so far is 2, and we have h to the 1/2 power would be equal to minus 1 over 10 times the root of 2 t plus c, which is 20. If I divide the entire equation by 2, I'm going to get h to the 1/2 power is equal to minus 1 over 20 times the root of 2 t plus 10. So what I just did there is I divided the entire equation by 2. Now to get rid of the square root sign or the 1/2 power, I'm going to square both sides. So I'm going to square both sides. I'm going to square both sides. So if I do, I'm going to get h is equal to 10 minus 1 over 20, the root of 2t all square. And that brings us to the last part of the question, C. And C is asking us to determine t when h is 50. C is asking us to determine t when h is 50. So I'm going to say when h is equal to 50, I'm going to get 50 is equal to 10 minus 1 over 20 root of 2t squared. All right, so to get rid of the square, I'm going to find the square root of both sides. All right, let's see, we can probably go up here. I'm going to find the square root of both sides. So I'm going to get the root of 50 would be equal to 10 minus 1 over 20, the root of 2t. All right, now the root of 50 is 5 root 2. So this is 5 root 2. The root of 2 is equal to 10 minus 1 over 20, the root of 2t. Bring this over to make it positive. I get 1 over 20, the root of 2t would be equal to 10 minus 5 root 2. All right, then T would be equal to 20, the root of 2, into 10 minus 5, the root of 2. All right, and of course, if we put this as it is in our calculator, you don't have to do anything special, just put it exactly as it is in our calculator. We're going to end up with T is equal to 82.84 minutes. All right, example 12. Example 12 says a rat has a mass of 30 grams at birth. The rate, sorry,